let me start the recording. Right, so these two y's will cancel out. For here, we will get the x, -4 plus 5 will be 1, so it's just 1x, and on the other side, we will have -3. Right, so we will find the value of the x. So you see what I did? I eliminated y, and I found the x, right? So I found the opposite one. Okay, now, absolutely the same result will happen if I multiply the second equation by -1, not the first one, right? Absolutely the same result, because once again, we can use different strategies, but we should be getting the same answer, right? Okay. Now, the second question will be, what should I do to eliminate variable x? Let me clear it up and go to our second item. So the system is unchanged. It's the same. But now I need to eliminate the x. In other words, I want to find y, right? So I want to eliminate these x's over here. Now, in this case, I will have to multiply both of the equations. So think about this. What should I multiply the second equation by? What should I multiply the first equation by, right? The goal is, after we add them up, to have x eliminated. The goal to eliminate x after we add them up, right? So think about this. Also, if you can, please put the answers into the chat messages. I'll give us a few minutes for that as well. And then I'll talk about it as well. Okay, so the first suggestion works. The third suggestion works. What they do basically is they change the signs, right? -5 and 4, and then 5 and -4, right? Okay, now let me go ahead and follow the suggestion number 1 to multiply them, because I already checked it, right? And it's working. So let me do this. I'll erase this. I'll move these suggestions over here. I will erase everything from here, and I will clear up this ones. Use my styler to do that. Oops. Okay. Here, because I need some space there, so I really need it to be erased. Okay, almost there, almost there. Apologies for the wait. Okay, so keep in mind, when we multiply the entire equation, right, by -5, and this one by 4. Okay, 4 times -5, -20x. 3 times -5, -15y. -5 by -5, +25. 5 by 4, 20x. 3 by 4, 12y, and then -8 by 4, what is it, -32, right? And now I add them up. This is where the name comes from, addition method, right? So because we add up the two equations after we multiply. Okay, so check these ones out. They're gone, right? -15 plus 12 will be -3y, and then 25 minus 32, what is it? I think it's a 7, right? It's a -7. Yeah, it's a -7. Because from 25 to 30, it's 5 and then 2. Yeah, -7. And now I should divide both sides of the equation by -3, right? To cancel this factor. Okay. So the y will be negative by negative is positive, 7/3. So we found the y. We eliminated the x and we found the y. And in item 1, we eliminated the y and we found, you remember what was it? Like it was x equals to -3, I believe, right? It was in item 1 that we found. So what we can do with these two methods is sometimes the question you get is not to solve a system of linear equations, but to find the y value of the solution or the x value of the solution. That's what we will have in the item 3, right? And depending on what exactly value you need to find, you will be eliminating the other variable. But before we go into that, let me know if you have any questions about any steps that I did here so far. Everybody's good? Okay, so let me clear all the drawings up and show you this question. So there are situations when you will not be given pairs of values for these solutions to check, but instead you will be given something like this. So find the y value of the solution and choose the answer. And you will be choosing between, let's say, -2, 3/7, 7/3, and maybe for -7/3, and so forth, right? So you're not given a pair of values. You're only given the second value here, the y value. So when you have a question like that, and unfortunately we don't have such questions in the homework nor in the Zai books, but what we used to have is the CIF exam, the one that used to be centralized by CUNY, used to have such questions, right? And just to get a better understanding, it's probably worth going over such questions. So I want to find the y value of the solution. So what do you think I should eliminate when I'm working on this system? Which variable, x or y? Right? Think about it. I'm not asking you to submit the answers in the chat message. Just kind of think about it for a moment. Right? So I'm asked for the y value. It means that the other variable has to go. So it's, you could solve the system of equations completely, find both x and y, and then give y as the answer, right? But you could simplify the amount, you could reduce the amount of work by eliminating the x. If you were to eliminate the x, and that's what we did in item 2, right? We found, no, we did it in item 1, right? In item 1, we found, where did we do it? Eliminate x. Okay, we did it in item 2. So if we eliminate the x, we find the y value because this is the variable that will stay, right? And we will solve for it. Okay. So x, right? The answer here will be x. To eliminate the x, eliminate the other variable. Okay, so this is kind of the idea of the addition or elimination method, right? Let's also talk about the substitution method. And for that, I have this example over here. I'm not sure that you were given a similar example in the Zai books, but what I want to point out is that this system begs for the substitution method to be used. I don't need to do any movings, right, or solvings here. No, I'm already told, hey, look, x is 5 plus 2y. So why don't I use this expression over here and plug it in instead of the x in the first equation? So this x will be replaced with the expression 5 plus 2y. What we will end up with, as this item says over here, is equation in only one variable, y. If I have an equation in one variable, y, I'll go ahead and solve it for y. So I'll get the value of the y. And then I also need the x. For that, I'll go back to this equation that I already kind of used, right? And I'll substitute the value of y into it, and I will find the x. So the substitution method, to tell you the truth, is really straightforward on what you do and how you can do it when it already looks in a nice way, right? When one of the variables is already isolated. And that's exactly what happened here. The x was the isolated variable, right? So this is the plan of work then. This is what I'm going to do. I'm going to use this expression over here for the x over here. I'll get the equation in one variable. Let me go ahead and do it. 5 parentheses 5 plus 2y. So you see how I replaced the variable x with this expression, right? Minus 6. Sorry. The Zoom messages came up. Okay. Y is equal to 21. Then I'll have to open up the parentheses, right? This one's use the distributive property. 5 times 5 gives me 25. 5 times 2 gives me 10y minus 6y equals to 21. Before I do anything in terms of moving, let me combine these two, right? So I'll be getting 25 plus 10 minus 6 will be 4y equals to 21. So I need to solve it for y, right? So I'm going to move the 25 to the other side. 25 travels to the right, minus 25, minus 25. Now on the left side, I have 4y. On the right side from here, right, 21 minus 25 will be negative 4, right? And then I will finish it up by dividing both sides by 4 because I need to get rid of that factor of 4, right? Okay, so y is negative 4 divided by 4 will be negative 1. I found the y. So I found the second coordinate, right, for the answer. I found the second coordinate. And now I go back. They called it backtracking, I think, right? I go back to this equation to find the x. So x is equal to 5 plus 2 times negative 1, right? So it's 5 minus 2 and it's equal to 3. So x is equal to 3 and I will plug it in over here into this position, right? So that the x is equal to 3. Now, look over the work here. Let me know if you have any questions. Now, all the answers I got so far are correct. So this is the pair of values. It is a 3 and 5. Okay, so the 3 stands for the x value and the 5 stands for the y value. Tell me, let me know, put into the chat messages, just pick up if you want me to solve the system, because since all the answers I see were correct, I'm assuming that everybody got them. But, we have more than that people, right, in the class. So if you didn't get them, let me know. I'll work on it. Okay, yes. So let me solve it. Let me work on it. What I would do first is I would start by plugging in this expression instead of this y under. So it will give me 2x plus 3 parentheses x plus 2 equals to 21. This is the first step, right? The next step is to open up the parentheses to use this distributive property over here. 2x is the same. I'll just copy it over. 3x from here, 6 from there, and then 21. So if you got up to this stage, wonderful. Now, these are two terms to combine. So don't send anything to other side yet. Combine like terms first. This will give me 5x, right? Plus 6 equals to 21. Okay, then I'm going to send the 6 to the other side. 6 goes to the other side. So meaning I'll do minus 6, right? So then it leaves me with 5x being 15, right? So it's equal to 15. And then the last step for me would be to divide both sides by 5, right? So then x is a 3. We got the value for x, right? That's exactly the first value I have over here. And then the last step for me would be to use this formula again. So keep in mind, like you're kind of using it twice, right? So I'll use this formula again. I'll plug in the value of x over here to get the value of y, right? So y is equal to 3 plus 2, which gives me 5, right? So the answer will be this there. Let me know if you have any questions about any work that I just did. Mhm, mhm, mhm. Okay, excellent, excellent, excellent. So now what we have on our plate is the special cases. Again, the special cases are, do you remember the two parallel lines and the same line? This is what we will be also seeing. What do we get for these cases algebraically, right? Because graphically we understand. For example, here, you remember no solution, the system is inconsistent. How did it look like on the graph? It was two parallel lines, right? Like two parallel lines like this. So for this case, we can see that the lines do not intersect. So there is no solution. And the system was called inconsistent. For this case, when there are infinitely many solutions, it was the case when both of the equations represented the same line, right? So every single point over here is a solution. That's why there are infinitely many of them. The question now is, how will it look algebraically, right? Well, let's solve this one and let's solve this one. At least let's try. Let's see what happens when we run into these special cases. I'm looking at the first one, and what I would like to do is to eliminate the x, right? So if I want to eliminate the x, I will multiply the first one by 2, right? That's all I need. Because check this out. 3 times 2 will be 6x, right? And then I have the negative 6x here, so it will give me 0, right? This is what I need to do. Let's go ahead and do it. So 3 times 2 will be 6x minus 2 times 2 will be 4y equals to 7 times 2 is 14. The second equation I'll copy over. Do you see what happens to the left side? Because I'm going to add it up now, right? Like I like to put this plus here. Do you see what happens to the left side? So Leo, the number 2, because I wanted to eliminate the x, right? My plan was to eliminate the x. If I multiply 3x by 2, I'll get 6x. You see my planning here, right? And 6x minus this 6x, right? This is when I will be adding them up, will give me 0. That's why I take 2. If I take negative 2, that will not work because here I'll get negative 6x, here I'll get negative 6x, so it will be negative 12x. So when I decide to which variable to eliminate, right, that's how I begin to plan the numbers out to multiply. Okay. Okay, now check this one out. I'm going to add them up, and what happens is both x is canceled and the y's are canceled, right? Because negative 4y plus 4y is 0, 6x minus 6x is 0. So I am getting the 0 on the left side. Okay, let's see what are we getting on the right side. 14 minus 15 would be negative 1. Okay, this is a weird statement. Am I claiming that 0 is equal to negative 1? I cannot because these are two different numbers. So what I'm getting here is a false statement, right? So first of all, both of the variables disappeared. Secondly, I got this weird statement, false. This is how it looks algebraically when we have no solutions. So for the parallel lines, when we will be working on these system of equations using addition method or elimination method, right? Substitution method, same thing. we will be getting a false statement. And it's very naturally associated to the no solutions, right? So if I'm getting some weird statement here, some false statement, means no solution, something is wrong with the system, it's inconsistent. Now over here, we will also be getting a statement. You will see that both X and Y will cancel. But the statement here we will be getting will be a true statement. Now, take a look at this one. No matter what you decide to eliminate, both of the variables will be eliminated. Think for a moment, if you decide to eliminate X, what would you multiply the first equation by? Think for another moment, if you decide to eliminate the Y, what number you will be multiplying the first equation by, right? Mm-hmm. By 2, yes, I agree. So I would multiply this equation by 2, right? So it will give me 4x plus 2y equals to 8. Copying down the second one, negative 4x minus 2y equals to negative 16. Add them up. See that the same picture happens here. The left side is completely eliminated, right? So let me show it. These ones are canceled. Oh, sorry, I erased something, right? Aha, I went to the wrong page. It's because the hand was working, the cursor. Okay, so these ones are eliminated and these ones are eliminated as well. And when they are eliminated, I'm getting the 0 here, right? And do you see my mistake? What didn't I do to the first equation? I forgot to do something. What did I forget to do? I forgot to, when I was multiplying, I forgot something. Can you spot it? I made a mistake.
To multiply 8.
Yeah, exactly. I forgot to multiply 8 by 2. So it's not 8, it's 16 here, right? So it's a very natural mistake to do. It's just probably when I'm not paying enough attention to it, it happens. I don't know, but it does happen. Okay, so 16 minus 16 will be 0. You know how different are these two statements, right? This one and this one. This one is false, but this one is true, right? So when we get that both of the variables are eliminated and we have a true statement here, it means that this system of equations has infinitely many solutions. This is the case of the same line, and the system is called dependent. Now, they usually don't try to catch you on the names of the system. What's important for us is that you understand whether it's infinitely many solutions, no solution, or just one solution. So we don't mix them up, right? Don't worry about that. Okay, let me know if you have any questions about the work I did so far. Now, what I would like to show you is how to convert them to the system with the integer number factors. And then I will solve it, right? But it's kind of two stages problem. So first convert and then second solve. So, if you have to rush, please stay for the conversion part and then you can go and just watch the recording on how to solve the system, right? To the very end. I understand that you might be, having some meetings and so forth. But check this out. I will be working with them separately. Now, we did have a similar situation before when we were solving linear equations in one variable. We used to have fractions there too. And the way we did it is we found the LCD, let me change the color because I need find LCD, right? Multiply both sides of the equation by it.
Professor,
Yes, go ahead.
I have to go, but can you send the recording of today's class? Is that possible?
It will be posted online on our webpage. Yes.
Okay, great. Thank you.
Yeah. Have a good day.
You too. Thank you. Bye.
Uh-huh. Okay. Now we will do it for each equation, right? For each equation that has the fractions in it. And then we will solve them, right? So, okay. And then the second step here, then solve the system, right? System. Okay, so this is what I'm going to do first. And let me check the chat messages. Yeah, yeah. So usually I try to post all the recordings by tonight. Sometimes they are not converted, they are not uploaded, but usually I try to do it the same day. It's, you know, in the evening sometime. Will do. Yeah, we'll do my best. Now, for the first one, the LCD will be decided upon looking at 4 and 6, right? So I have two denominators, 4 and 6. What's the lowest common multiple, right, of them? Not the 24. So the 24, if you think about it, will be just a common denominator, but the LCD will be exactly 12, right? So it's the smallest of them. Now, CD will work as well. You know, don't worry if you cannot find the LCD, find the common denominator, that's fine, that will work too. I will work with the lowest common denominator. Now over here, I don't have many fractions, I have only one, right? So what I will do then is I will use the 4 and I will multiply both sides of the equation by it, right? And yeah, I can call it LCD, right? It's only 4. And multiply both sides by it. Same here, multiply both sides of the equation by 12. So let's go ahead and do it. 1 over 4x times 12 minus 1 over 6y times 12 equals to 2 times 12. What is it? 2 times 12, 24, right? Now I'll be doing this one separately. 3 over 4x times 4 plus y times 4, 4y equals to 3 times 4, 12, right? Now, in the first one, don't forget that any whole number can be rewritten as a fraction, and then we will do some cancellations. I cancel 4 from here, get 1. Cancel 4 from here, get 3. So I end up with having 1x times 3, what it will be 3x, right? 3x here.
Question: why do you subtract? Excuse me. You divided the 12 by 4.
Yep, you could say it this way: divided 12 by 4. Yep.
So is it cross multiplication?
No, this is cross cancellation.
Cross cancel. So I'm just curious. I'm sorry. Like, how does that work?
You cancel one common factor from the numerator and one common factor from the denominator. Like imagine you had 12 over 4. So you cancel 4 from the numerator, from the denominator, right? Cancel means divide. And you cancel one common factor from the numerator. That's how we got.
Okay, got you.
Okay, now over here, the same sequence of movements, right? So 6 divided by 6 will be 1, 12 divided by 6 will be 2, right? So I am getting minus 2y because 1y multiplied by 2 will be 2y, and then this minus stays, right? On the other side, I have a 24. Done with the first equation. The second one is easy because you could see the similar cancellation over here. Cancel 4s, right? Get 3x plus 4y equals to 12. So now what I can do is I can form them into one system. Let me move this one over here. So 3x plus 4y equals to 12. So this is my system, new system without any fractions, and I'm going to solve it, right? Solve it. Let me know if you have any questions about the work done so far. Okay, so what I will begin with is I will eliminate x. Let's eliminate x. I just decided to eliminate x, right? Eliminate x. So I'm looking at these two. They already have the same number of factors and they have the same sign. Well, I don't want the same sign. I want the sign to be different. So I need to multiply this one by -1, right? So this will be negative and this will be positive. So it means for me that the entire first equation should be multiplied by -1, right? Let's go ahead and multiply it. And now
Question,
I'll change.
could you have done it either way? Like could you have done the bottom by -1 and it's still
Exactly. Yes, you
yeah,
can do any of them. Mhm.
okay.
Yeah, you're absolutely right. Okay, so when I multiply the -1 by every single term in the equation, I'm getting -3x plus 2y equals to -24. The second equation, I'm simply copying over. Don't do anything to it, right? And then I add them up. This is when these two will cancel, right? And it will give me 2 plus 4, 6y is equal to -24 plus 12, -12, right? And I'll finish working on it by dividing both sides by 6 so that the factor of the y cancels. So then y is equal to -2. That's my first value, right? So when I will be putting the answer, right, the second place would be occupied by the -2. I need to find the x though, right? And you remember how I said that you can use this value in any of the original equations? But when you have fractions, who likes to deal with fractions? So here we have kind of an amendment, right, to that guideline. They say, well, you know what, you could use it there or you could use it here, right, in this system. So what we could do then is we could use this value in this equation, in this equation, in this equation, and in that equation, up to us, whichever we pick. And, you know, let's say, let's pick this one, pick it, right? Let's pick this one. So we have 3x minus 2 times, and here goes the y value, right? -2 equals to 24. Okay, so from here, from this multiplication, I'll be getting 4. 3x plus 4 equals to 24. Then I need to send this 4 to the other side. Let me pick a different color like this, right? So -4 minus 4. Now it gives me 3x is equal to 20, right? And then I need to divide both sides by 3. Okay. You see that x is a fraction, right? And I can actually put it up as the answer. 20/3 will be absolutely fine. Or if you wish, we could convert it to a mixed number. We just usually don't do it in here. But how many 3's fit in? 6, right? 6 times 3 is 18. 20 minus 18, 2/3. This one, right? This could be put in the answer. But it's just what we usually do is we prefer the first version. Okay. So this is it. And if you have any questions, please feel free to stay and ask. If you don't have any questions, you are free to leave. Just don't forget about the homework assignment, right? The homework number 14 is already up and it's due this Friday. So don't forget to work on it.